All right, this is chapter 4. This is lesson 1. This is the first part of lesson 1. And you should be watching this. This is Thursday, March 8th. So sometime March 8th, 9th, 10th, 11th. Hopefully you're watching this. And we're going to look at now chapter 4. In chapter 4, we switched completely. And now instead of using the sine and cosine to solve triangles or things like that, we're going to look at the graphs of a sine and cosine. And this will be completely different than anything you've done before in geometry with the trig functions. And first thing we just want to note is sine and cosine are going to be periodic functions. And a periodic function is something that repeats itself over time. And there's not been any other function prior to this that you've studied that's been periodic. If you've talked about lines, parabolas, ellipses, hyperbolas, none of those were periodic. None of those would repeat themselves. And sine and cosine are different because they repeat themselves. That makes them very valuable because in the real world, lots of things repeat themselves. Temperature, heartbeat, amusement park attendance, voltage, gas prices, all these things repeat themselves over time. Because with temperature, I don't know if you guys have ever noticed, but about November, December of every year, I don't know if you've noticed, but it starts to get cold. And it happens every single year. You get this periodic repetition of temperature. It gets cold, then it gets hot again in, May, June, July, it gets hot. Then November, December, January, it gets cold. And it repeats every single time like that. And now we want some kind of a function that will model things that repeat. And that's where we'll turn to our sines and cosines. Okay, so sine and cosine we're going to find out are periodic. It's going to turn out they repeat every 2 pi radians or every 360 degrees they will repeat. Let's look at the graph of sines. We're going to try to find the graph of the sine. And to do this, we want to plot points. To get points, we'll go back to our unit circle. And you guys have made that unit circle. Some of you guys are really good at creating that unit circle. But remember, we had a 0. And up here, the measure was pi halves and pi and 3 pi halves. And if you remember, sine was the y coordinate. So if I had the ordered pair here, oops, try that again. The point was 1, 0. Or here the point was 0, 1. Here it was negative 1, 0. Here it was 0, negative 1. And then you had some other values in here. I don't know if you remember. We had pi fourths and 3 pi fourths and 5 pi fourths. I know we had even more than that. Over here, 7 pi fourths. We had some of those values. And if you come around that unit circle, our x was our angle. We had 0, pi fourths, pi halves, etc. And then the y coordinate, and then the y coordinates were the y coordinates. The sine of 0 was 0. The sine of pi halves, look, it's right here, it's 1. The sine of pi is 0. The sine of 3 pi halves, negative 1. And then from your chart, you remember you did the fourth value, so the sine of pi fourths was square root of 2 over 2. It's a little hard to graph square root of 2 over 2, so we give the decimal approximation, which is about 0.7. And that's where this comes from in the chart. And again, the 0, pi halves, pi, 3 pi halves, you can read right off our unit circle. And then the other ones with the pi fourths, because square root of 2 over 2 is about 0.7. And notice in the third and fourth quadrants, our values are negative. So now that we have this chart with our values, and again, look at your unit circle if you're not sure where those came from, we can graph. And our x-axis, we're going to take this out to 2 pi. This would make this pi. Here's pi halves. There's 3 pi halves. The biggest our sine ever gets is 1, so we can kind of choose our scale. Here's 1. Here's negative 1, and we plot our points. Sine of 0 is 0. Sine of pi fourths is 0.7. Pi halves is 1. 3 pi fourths, 0.7. Pi is 0. 5 pi fourths, look at this, negative 0.7. 3 pi halves, negative 1. Another negative 0.7. And the sine of 2 pi is 0. Now we take those points, we connect them with a nice smooth curve. And this gives us a good look at our sine graph. If you want to see a nicer graph, we'll look at our calculator picture on the next page. And the calculator plotted a lot more than our points here. It plotted 100 points just about. And we look at that, and here's that graph of a sine graph. Now you will want to be able to make this graph by hand, and you won't want to plot all those points every time, but you will want to know 4 key points. You'll want to know the sine of 0 is 0. The sine of pi halves is 1. The sine of pi is back to 0. And 3 pi halves is negative 1. And again, I think the easiest way to keep that in mind is just on your unit circle. Remember, sine is the y-coordinate. And you trace around the values on the excuse me, the values are the y values as you trace around. So we go 0, 1, 0, negative 1, and then back to 0. So those will be the values down here that you'll want to memorize for your sine graph. You'll plot those points, and then you know, let's connect that with a nice smooth curve. Okay, that's our sine graph. Let's take a look at our cosine graph. The table we would make in the same way, except for cosine. You know, we're looking at the x-coordinates. So we establish our table in the same way. We'll set up our graph down here. Very similarly, we've got 2 pi and pi halves and 3 pi halves. We'll go up to 1, down to negative 1. We'll plot our points. The cosine of 0 is 1. Pi fourths is 0.7 again. Then a 0, then already we're down to the negatives. And a negative 1 and a 0.7. And we connect these dots to get our cosine graph. Possibly you're looking at a cosine graph thinking that looks a lot like a sine graph, and you're right, it does look a lot like a sine graph. We're going to find out more about that later. For right now, we'll just say, okay, that is our cosine graph. Check out the next page. We've got a very nice looking cosine graph there plotted by our calculator. And the same thing, you want the key points for cosine. These are the points that you will want to memorize as you're plotting this. And again, maybe memorize is a bit strong. Really, if you think about your unit circle, cosine are the x-coordinates as I come around. So I look at the x-coordinates. Cosine goes from 1 to 0 to negative 1 to 0, and then back to 1. 1, 0, negative 1, 0, and then back to 1. So those would be the key points as you're plotting a cosine graph. And you know from this graph here, it's nice and smooth, so you connect those dots with a nice smooth curve. So those are our two kind of parent graphs that we start with, a sine graph and a cosine graph. And now the thing is, we said before, these are periodic. So if you look beyond this 0 to 2 pi and your graph beyond that, oops. So let's look between negative 2 pi and 2 pi and see what these look like. Here's our sine of x ready to graph. Let's set our window, negative 2 pi to 2 pi. And graph beyond this, we see we get this graph where our sine just keeps repeating. We don't get, I'll move this over here so you can see it slightly better. We don't get just one cycle of the graph anymore. You get the same cycle that we had here, 0 to 2 pi. You get it again. And if you took your window out further, what would happen? It would keep repeating, and it would keep repeating in both directions. Again, in the real world, lots of things repeat. Maybe these are temperatures. This is the high temperature. This is the low temperature. And maybe this is a 365-day cycle. It goes high, low, etc. But it keeps repeating. And the cosine, we got cut off here from negative 2 pi to 2 pi. Very, very similar. Let's come up here. Let's change this to cosine. And sure enough, we get the same cycle over and over again for cosine as well. And again, if that window was bigger, it would just keep repeating. And you haven't had functions like this before that keep repeating, so periodic functions. All right, the next thing we'd like to do, we said we can use these to model things. We'd like to change the amplitude. And the amplitude of a wave is how high does it go? How far up does it go? How far down does it go? And the way we define it in math is you take the middle and how far you're going up or how far you're going down from that middle, or half the difference from the maximum value to the minimum value would be the amplitude. So let's consider for a minute sine and cosine. Here's our cosine graph. Let's bring that back down here. The sine would be very similar. What is the amplitude? Oops. Take that off. Sorry about that little technical difficulty there with that circle popping on, but I paused it, we got rid of the circle. Let's go back here to our cosine graph. It's a little unprofessional here, but we'll be all right. So our high point is 1. Our low point is -1. If you take 1 minus -1, the difference between the high and low, it's 2. Take half the difference, and we'd say that amplitude is 1. Or again, just look at the graph. From the middle, how high up do you go? 1. From the middle, how far down do you go? 1. So we say the amplitude of our graph is 1. Okay, if we really want to model things, we'll want to change that amplitude. Because temperatures vary by more than 1. They don't just go up 1 and down 1. They go up, 30 or 40 or 50 degrees and down 30 or 40 or 50 degrees. So it'll be important for us to be able to change the amplitude. So let's consider a graph like y equals 3 sine of x. Wild guess what you think that 3 does to the amplitude. So let's put two graphs here. Let's put sine. That's our regular sine graph. And then let's put in here 3 sine of x. And let's see what the difference is. And let's maybe make the second one dark. There we go. So we've got the dark as the 3 sine of x. We'll hit graph. Here comes our first one. And here goes our second one, except it kind of shoots off in the screen. So let's change our window. And our y min, look at that, it was -2. But it shot down below that, so let's go -4 to 4. Graph that again. Here's our sine graph. And here's 3 sine of x. So what does the 3 in front do? Hopefully you can see very clearly it affects the amplitude. So we have 3 sine of x. Take a look at that. It now goes up 3. It goes down 3, so we have a different amplitude of 3. I bet you can guess 4 cosine of x. Are you thinking about a regular cosine graph? That starts at 1, goes like this. Well, what would 4 cosine do? Count up 4, it's going to be 4 times as high and 4 times as low. That's a little sloppy. Let's see if the calculator can give us a better picture on that. So same thing here, we've got cosine. And now we've got 4 cosine. Hit graph on both of those. There's our cosine. Ooh, I like that a lot better than my graph. And there's 4 cosine. So it keeps the same shape. I'm going to cover mine up, I think. Keeps the same shape, but it increases the amplitude, so it's 4 times bigger. All right, is this something you think you can do on your own? I bet you could. Actually, one more I want to show you, and then we'll have you try this on your own. And here, let's try a negative sine of x. What do you think that negative in front does? And a negative, is like a -1. So let's just consider that for a second. So here's y equals, we'll clear this out, clear that out. And let's go a negative sine of x. Hit graph on this. And it looks just like a sine graph, except the exact opposite. Everything got flipped over. Remember our sine graph? It came up here and went down here. So now it goes down first and up second. So you got the mirror image of our sine graph with a negative in front of it. So our main point for this first lesson is the number in front affects the amplitude. So a sine of x or a cosine of x, either way, that a is the amplitude. We'll take the absolute value. So if somebody sticks a negative in front, -4 cosine, the amplitude is still 4. Let's take a quick look at these other pictures here. We should be good to go. So could you graph something like 2 cosine of x? Well, let's set our scale. Let's maybe make this 1, this 2. Down here, -1, -2. What does a regular cosine graph look like? And again, we'll label this as well. That's 2 pi. A regular cosine graph looks like that. So what does 2 cosine of x look like? It starts up at 2, goes down to -2, back through 0, and up. Coming the other way, these are periodic. It would be the same. All right. What would -3/4 sine of x Well, let's call this 1, call this -1. Let's call this our 2 pi again. And negative, well, it's going to start at 0. And instead of coming up, -3/4 will go down to 3/4. Back to 0, up to 3/4, and back down to 0. And it would be the same going in both directions. Oops, off a little bit there, but not too far. So this is our idea today. What would you do with the number in front? Well, it affects the amplitude. It affects how high or how low the graph goes. And that is all that is on your sheets. So hopefully this is making some sense. On Monday, we're going to practice some of these in class. And if you have questions on any of this, certainly, make some notes and we'll go over those questions. Thanks for watching.